Videos talking about the trigonometric ratios. In other words, this is talking about trig. And basically the idea is that there exists a relationship between the angles of a triangle, whether it's a right triangle or some other type of triangle, mainly right triangles, and the side lengths that make up those angles. So the idea is that there's a relationship that exists between these sides and the angles that make them up. Okay, so if we shorten one side, that's going to change the angles. If we lengthen one side, it's going to change the angles. And that's kind of the idea. And the ancient Greeks kind of came up with this idea. So what happens is sometimes we use some different terminology. You'll see it every so often. But the idea is we use variables like x, y, z, maybe a, b, and c. And sometimes we even use capital letters A, B, and C, something like this. Since the Greeks came up with this, sometimes you'll see Greek letters in this. This is the Greek letter theta. And sometimes you'll see this letter either pronounced phi or phi, depends on who pronounces it, I guess. And these basically are going to represent, mainly for us, they're going to represent angles. And sometimes you'll see it in geometry, and sometimes you have to wait till pre-calc or calculus to see these letters. But they do pop up every so often, and people are usually shocked by them. They're usually just kind of a big letter O, like a capital O with some sort of cross through it this way, this way. Sometimes you'll see them a little bit more kind of squiggly, kind of like a cursive O. You'll see it sometimes that way, but just so you're ready for it. When we use angles in this class, we'll usually use the capital letters A, B, and C, where all these lowercase letters generally are going to talk about side lengths. Okay, so lowercase letters, side lengths, uppercase letters mean the angles. Well, let's get down to it. There's three basic trig functions. One's called sine, one's called cosine, and one's called tangent. Okay, and these are abbreviated sine. And usually you'll see like of some angle. This is the cosine of theta, and this is the tangent of theta. And in your calculator, you'll notice these three. There's three buttons usually above the 7, 8, and 9: sine, cosine, and tangent. Okay, there's usually their inverses if you use the second in that piece. Well, there's a ratio that exists that if we talk about a right triangle, let me talk about this triangle first. This is always the hypotenuse, which is across from the right angle. And if I say that this is my theta down here, then I could talk about this side over here being the opposite side for my angle that I'm given. So it's the opposite side of my angle. This is then called the adjacent side of my angle. So this is adjacent to the angle, this side is adjacent to the angle, this is the hypotenuse, and this is the side that's opposite my angle. It's really important that we talk about it this way. Let's not talk today about the long leg, the short leg, and the hypotenuse. Instead, it's the opposite side, the adjacent side, and the hypotenuse. And depending on where this angle is, if I would have picked this angle up here maybe, well, for phi or phi, this now becomes the opposite side, the adjacent side, the hypotenuse stays in the same place. So it really depends on what angle you're talking about and where you're talking about it to determine where these are at. But no matter if I'm going to talk with theta, the sine is always the same. It's always the same. It's always the ratio of the opposite side divided by the hypotenuse. The cosine is always the adjacent side divided by the hypotenuse. And the tangent, oh, I wish I would have drawn this better, is always the opposite side over the adjacent side. And there's a quick, easy way to remember this. It's this idea of SOHCAHTOA, where the S stands for the sine, that's the opposite over the hypotenuse, which I set up here. This is the cosine, it's the adjacent over the hypotenuse, which is here. And tangent is opposite over adjacent. Some teachers come up with clever ideas talking about how SOHCAHTOA is the stepsister of Pocahontas, and they talk about how she goes on this amazing adventure to find like the height of some teepee or something like that, or they talk about how you bump your foot and all of a sudden in order to get better you have to soak your toe, and I'm like, I don't know. I don't really have some crazy way to remember it. The idea is just to remember SOHCAHTOA. There's only really one way to spell it if you know that you're talking about opposite, hypotenuse, and adjacent. SOHCAHTOA. Important thing, whatever degrees they give you, such as like 19 degrees, I think the very first step is always to identify, hey, this is my hypotenuse, this is my opposite side, this is my adjacent. And if they come over here, they say that, hey, this is 26 degrees, we'll again identify this is the adjacent side, this is the hypotenuse, and this is the opposite side of that angle. Okay? If they came up here and said that this is, 45 degrees up here, okay, then I could say this is my opposite side, this is my adjacent side, and this is my hypotenuse. Okay, so it kind of depends on what placement they give you, what placement of the angle, to figure out where these go. The opposite side's not always on the right. The adjacent side's not always on the bottom, as you can see here. They can kind of move around depending on what angle you're given. And we'll see that as we go on. So the important things to take away, SOHCAHTOA. Today we're going to focus primarily on TOA. So this is the tangent trig ratio. It is a ratio between the lengths of two sides of a right triangle. Specifically today we're going to talk about the leg opposite of A and the leg adjacent to A. Again, everything's based on our one angle. This is kind of a quick way to see it. And again, it's called tangent. In your calculators, you'll see it abbreviated tangent, tan. Another thing to note, if you are using a calculator, your mode, if you're talking about degrees, we want to be in degree mode. So check your calculators. If you have a mode button, just make sure that it says degree or degrees as opposed to radian mode. Watch out for this. If you're working with degrees like 75 degrees, you do not want to be in radian mode. If you're dealing with like pi over 2, that is radians, so you can be in radian mode. But until you see something like this and know what this means, do not use radian mode. It'll mess up all your answers, so be careful. Okay, so we're given this, and we're trying to find the tangent of A and the tangent of B, and it tells us, hey, write your answer as a decimal rounded to 4 decimal places. So what I'm going to do is I'm going to identify A, and I'm going to find the tangent of A. Well, the tangent of A says that if I have A, this is going to be my opposite side, this is going to be my hypotenuse, and this is my adjacent side right here. So opposite, hypotenuse, adjacent. Tangent is always the opposite over the adjacent, and I see some people actually write this out, opposite over adjacent, which is just like that, piece of cake, or they write out the abbreviated term. They just say that's 45 over 28. So that's the exact answer. Then it says rounded to 4 decimal places. You put that in your calculator and everyone should get 1.6071. You may have to round it so you get there. Secondly, I'm going to come over here, I'm going to change colors really fast, and I'm going to find the tangent of B. Okay, so now I'm looking from this angle. What happens is, this is not my adjacent angle anymore. For B, this is my opposite side. And this opposite side is no longer opposite, this is now my adjacent side. Looking from B, this is my adjacent side, this is a hypotenuse, this is now my opposite. So when I find the tangent of B, that's just going to be, again, the opposite over the adjacent, which will equal 28 over 45, which is just going to equal 0.6222. One student asked me today if I could just write this. Technically, some places don't recognize this, so don't do this, just write out 222. It's not a huge deal. If it wants it to 4 decimal places, probably just write out all 4 decimals. This is kind of an old school way of doing this, just so that you can see what your answers are. Why don't you guys go ahead and try this problem? I'll give you the answers in just a minute. Welcome back. Hopefully you found the tangent of A to be equal to 56 over 33, which is equal to 1.6970. We have to round that a little bit. Tangent of B, again, we'll switch this. This is going to be 33 over 56. It's actually the inverse, or the reciprocal, and that would be 0.5893. It's actually an interesting idea that you can actually use the inverse button on your calculator, and if you have this answer, you can actually hit this button and it'll give you this answer back. So it's kind of an interesting deal, which usually only works with tangents if you're doing complementary angles. The next part down here, this is actually a fairly useful thing for us. It says find the value of x to the nearest tenth. Given that this is 50 degrees, I would say I'm given the opposite side. Here's my hypotenuse, which I don't really am given. This is my adjacent side. I would ask what trig ratio deals with opposite and adjacent. Well, duh, today that's going to be tangent. So I would say the tangent of 50 degrees equals the opposite over the adjacent. And then I have to solve for x. Solve for x, I'll just simply cross multiply. If you picture this as a ratio, I would have x times the tangent of 50 degrees equals 13. The tangent of 50 degrees, again, is some number like these numbers up above, okay? So I just treat it like it's a number. I don't multiply, I don't distribute anything else. So I'm just gonna, I had it over here, I'm multiplying. To get the x by itself, I'll just divide both sides by it. So I'll divide by the tangent of 50 degrees. When you put this in your calculator, be careful and make sure that you get somewhere around 10.9. If you don't, try checking your mode, try checking a couple other things, check with somebody else. Until you get this as 10.9 in your calculator, do not move on with this video. Try the second one on your own, and we'll come back and we'll meet together in just a second. Welcome back. Hopefully you found that the tangent of 24 degrees. You said this was the opposite side, this was the adjacent side. So you'd say this is going to be just 9 over x. When you cross multiply and divide, you get 9 over the tangent of 24 degrees. So you get x equal to approximately 20.2. At this point, I want to actually give you an extra example here. I just want to show you something just a little bit different. I'll just draw a quick triangle here. If I can find how to draw a triangle. We'll draw this guy right here. There we go, there's a triangle. Let me give you some numbers really fast. I'll use red. We'll just say this is 17. This is going to be x. I'll put my theta right here, and we'll have to solve. Okay. In this case, we would say that the tangent. Actually, I need a number. We'll say this is 41 degrees. So we'll say the tangent of 41 equals my opposite, which is x over 17. In this case, I'll just multiply both sides by 17, and I'll get 17 times the tangent of 41 degrees. This is really handy. Algebraically, this is actually a lot easier than some of the things that we had been doing when we have to cross multiply and divide. I just want to show you that there was a different way to do this, and what you'll get is you'll get 14.8 would be our value for x. So sometimes you're not always just dividing. Sometimes you have to look at this and say, okay, what am I doing? Oh, this guy's had to multiply. In the previous cases, you had to divide. So it is worth writing this ratio out to figure out what do I need to do. Okay, this question is kind of interesting. It says find the area and the perimeter of each triangle, round the nearest tenth if necessary. So in this case, in order to find the area, remember that's going to be 1/2 the base times the height. So what that means is I'm going to have to be finding basically the other two sides of the triangle. And what I would suggest is that you go ahead and use the trig ratio, the tangent, in order to find one side, probably this side over here. And then once you have that, use the Pythagorean theorem in order to find this side. I'm going to zip through this problem fairly quickly, and I'll leave the second one for you to try on your own. The tangent of 71 degrees is going to equal the opposite side, which is 34, over x. When I cross multiply, I can get x equal to 34 divided by the tangent of 71 degrees. When I put that in my calculator, x would equal 11.701713885. Because this is not the answer I'm looking for, because they're not asking me, hey, find the height of the triangle, because they're not asking me to do that, I cannot round this calculation. This talks about accuracy, if I can spell accuracy correctly, that's kind of funny, and precision when in mathematics. If you're not asked to find the height, that's not part of the problem, you probably should go ahead and use all the digits that are in your calculator. Just leave them in there in your calculation. So find the area, you're going to use, it's 1/2 the base, which I'll say is 34, times the height, which is like 11.707, and sometimes I just write ... to say I'm using all those digits. In your calculator, you should get the area equal to 199.0 square feet. Some teachers really like it when you put this 0.0 here at the end. Others are like, well, that's stupid. So when it does say if necessary, I think it's okay to leave that A off of there. Next, it says the perimeter. So I'll basically take 34. I'll add to it this 11.707 number, and then I'll have to add my hypotenuse. So I have to find my hypotenuse in some way. If you remember that using the Pythagorean theorem, we'll just say that 34 squared plus my 11.707 number squared has to equal my hypotenuse squared, which is over here, hypotenuse. Or in other words, your hypotenuse is equal to the square root of 34 squared plus 11.707 squared. And I will calculate my hypotenuse to be, oh, it's a big number. I'm just calculating it right now. It's the square root of 34 squared plus I'm just working on it. Thanks for being patient. Wish I had a joke to tell you. Oh, I messed up while calculating it. That's kind of fun. Sometimes I just calculate stuff and just kind of, sometimes I don't. Apparently today, I did not calculate that well enough for me to remember what it was. Make sure you also hit the right buttons when you calculate stuff, or else it's very awkward, especially when you're being recorded. This is about 35.959, something like this. I'll just add these numbers together. The 11707 number, as well as the 34. That should give me a perimeter. If I round to the nearest tenth, my perimeter equals 81.7 feet. Okay, why don't you guys go ahead, use the same methods using precision and accuracy in order to find the values here. We'll meet back in just a second. Okay, we're back. If you did this correctly, your area was going to be 180.0 feet, and your perimeter would equal 67.3 feet. Again, this is going to be squared. Sorry I didn't put that on there. There's a lot of application problems for this. One is like a drive-in movie theater. Once you have this, it's actually kind of interesting. You can use this in a lot of different places. With this 58, this is going to be my adjacent side. This is going to be my hypotenuse, or my opposite side over here. I'll just label this with a variable such as h for the height of the movie screen. It says you are 50 feet from the screen at a drive-in movie. I would not recommend this. This is way too close. Your eye is on the horizontal line at the bottom of the screen, and an angle of elevation to the top of the screen is 58 degrees. Don't ask how you found that. That's kind of weird. How tall is the screen? Well, again, we have 58 degrees as our adjacent, this is our opposite, so we can use a tangent function. We'll say the tangent of 58 degrees is going to be equal to the opposite, which is h, over our adjacent, which is 50. We just multiply both sides by 50. 50 times the tangent of 58 degrees. And we should get our height to be really close to 80 feet. This tip at the bottom here just says that the complementary angles in a right triangle A and B are complementary angles. To find the tangent of A and the tangent of B, notice that the leg adjacent is the leg opposite, and the leg opposite is then the leg adjacent to B. So it depends on what angles you're looking at. It depends on what's going on. Again, if this is like 10 degrees, you could quickly find that this is going to be a complementary angle of 80 degrees, or vice versa. Another interesting example, we can talk about rockets. Kind of a cool way to go through, and depending on what angle you launch your rocket at, you'll get some different answers. Why don't you go ahead and try these answers? You'll notice that this is kind of a small answer, this is a bigger answer, this is even a larger answer. They're all fairly big, you are definitely launching these pretty high in the air. It depends on your height, how you can do this. The last problem is kind of a skyscraper problem, kind of interesting. Definitely a made-up problem. It's very ridiculous, very contrived to try to figure out what's going on. It says you were a block away from a skyscraper that is 780 feet tall. Interesting that you know the height of that. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is 42 degrees. The angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? This person who's writing this problem must be very omniscient, because the idea is that somehow they can tell the angle, but they can't tell distances. So I think it's very contrived. It's all right. What we'll do is we'll actually go through and we'll find the distance here. We'll just call this, since this is your friend, we'll call it f. And then we'll find this entire distance from this whole thing, and we'll call this u because it's your distance from there. So what we'll do is we'll just say this is going to be the tangent of 71 degrees is equal to the opposite, which is 780, divided by u. And then we'll say the tangent of 71 degrees, I'm sorry, this should be the 42 degrees, equals 780 divided by f. Okay, so 71 is just going to be this distance here. The u is the entire distance. We'll say that u equals 780 divided by the tangent of 42 degrees. We'll say f is going to equal 780 divided by the tangent of 71 degrees. What we'll do is we'll calculate these two numbers, and we'll actually take u minus f, and that'll give us our distance from our friend. Actually, it'll be our distance in feet. So why don't you guys check that out, solve that problem, and good luck to you with the rest of your math.